Hello everyone, Mr. Minix. My name, math, is my game, and today I'm gonna be pre-recording this lesson so that in my absence on Wednesday, I've got a family matter to go take care of. Anyway, I hope my geometry class is attentive and has their phones away, and anybody else who might be watching this back in YouTube land, I hope you enjoy. So this is the third section out of the geometry textbook that we're using. It's a McDougall-Lytle book. It kind of corresponds to the Common Core Content Standard. So here it is, Chapter 1, Section 3, Measuring Segments. Measuring segments. Now, my geometry class, they'll have a nice little packet of notes that they can follow along with, and basically they just have to fill in the blanks as they go. So hopefully this will go pretty quick. The Common Core Content Standard associated with this lesson is that sophomore students or geometry students, whether they're sophomores, juniors, seniors, whatever, or freshmen, should know precise definitions of an angle, of a circle, of a perpendicular line, parallel lines, line segments, based on the undefined notions of point, line, distance along a line, distance around a circular arc, etc. So the objective is to compare lengths of segments. Now, the last lesson we talked about how to name segments, so here we're going to be comparing the lengths of segments. So this first item here in the notes, it's called the ruler postulate. Postulate 1-5, the ruler postulate, says every point on a line can be paired with a real number. This makes a one-to-one correspondence between the points on the line and the real numbers. The real number that corresponds to the point is called the coordinate of the point. So the ruler postulate allows you and me to measure the lengths of segments using a given unit to find distances between points on a number line. So they're saying consider line AB at the right. Notice that notation means we're talking about line ABs. Consider line AB at the right. The distance between the 2 points A and B is the absolute value of their coordinate, of the difference of their coordinates. Now that's a complicated way of writing it, but it's a fail-safe way of writing it. The reason they write this that way, and the reason the ruler postulate is the way it is, suppose A was at 8. And B was at 11. Now most of us know that from 8 to 11 would be 1, 2, 3 units. Those aren't evenly spaced, but you get the idea. From 8 to 11 would be 3 units, and most of you know that the answer is 3. Well, if you were to take the difference between 8 and 11, you would take 8 minus 11, which is -3, but distances aren't negative. So that's why they use the absolute value, because whether the distance is positive or negative, it's going to be a distance away. It's going to be, 3 units away. So basically the deal is subtraction's not commutative like addition is. So that's why they use the absolute value. Okay. This value is also AB, or the length of AB. So to clear a few things up then, what they're saying is here you've got line AB. So when you refer to the whole line, it's line AB with the thing above it like that. Okay. Well, then when you talk about the distance from point A to point B, you're talking about segment AB. You're talking about segment AB. All right. So that's segment. Well, that's where you're talking about the segment. Here's where you're talking about the line. Well, the second you take the hat off of it, you're talking about the distance that it is from A to B, or the distance from A to B, or the length, or the actual length of that segment. Okay. So I know notationally they all look the same. It's A and B. Well, with the line above it, it means line AB. With the segment symbol above it, it's talking about the segment. When you drop that segment symbol and when it doesn't have a hat on it, AB is referring to an actual number, the length of that segment. You'll see hopefully in a few examples. So problem 1, it says, what is ST? Well, you might say ST is a line segment from S to T. Well, it is. But when they're asking what is ST, they're looking for a number. ST would be the absolute value of the difference between the coordinates S and T. So following the ruler postulate, we would set up that equation, because the coordinate of S, is -4. The coordinate of T is 8. So the absolute value of the difference between -4 and -8 would be the absolute value of -12, or 12. ST equals 12. And if you're not sure, you could always do it the old-fashioned way. 2, 4, 6, 8, 10, 12. Okay. In the got it section, it says, what are UV? Well, UV are rays that are dangerous, and that's why you should wear sunscreen. But in this case, UV is the distance from U to V. So we would write UV equals, now the coordinate U is 10. So the ruler postulate says absolute value, coordinate of the point U, which is 10, minus the coordinate of the point V, which is 14. So 10 minus 14. So that's the absolute value of -4, or 4. UV is 4. Again, you could count 2, 4. There it is. Finally, SV. SV. SV would be the absolute value of the difference between the coordinate S, -4, and V, V is actually 14, so it would be the absolute value of -18, or 18. SV is 18. Okay? So hopefully that's a piece of cake and you got the hang of that. The segment addition postulate, I don't know, to me this just seems so sensible, such common sense. Yet every year students struggle with this. I don't know why they do, but they do. The segment addition postulate says, given 3 points on a line, now we could call that line AB, we could call that line AC, but given 3 points on a line, A, B, and C, with B between A and C, comma, the following is true. The following is true. Now this is talking about the addition of a segment. Okay, so when we talk about the length of when we talk about a segment itself, for instance, this segment would be segment AB. But when we talk about the length of that, remember we dropped the hat. So watch and be real mindful of what these characters represent. So what we're saying then is, if we were to take the distance or the length of AB, if we were to take the length of segment AB and we were to add that to the next segment, as BC, the length of that, if we were to add BC to that, that when we combine those two segments, the one with the other, that it's equal to the length of the entire segment from A to C. Okay, to me it makes perfect sense. The short segment plus the longer segment, when you put those lengths together, it matches the length of the whole segment from the one end point to the other end point. I don't know why students struggle with this, but they do. Now, I might have mentioned it. If I didn't, geometry is not much different than algebra, but there's a lot of algebra in geometry. The main difference is you're going to have to write the equation. I'll say that again. You're going to have to write the equation. They're not going to have an equation for you to solve. You're going to have to write the equation and solve it. So let's look at this next example. They're saying, if EG equals 59, what are EF and FG? Now somebody might guess. Somebody might say, okay, well half of 59 is a little less than 30, so maybe one's 30 and one's 29. Well, we don't know for sure. And you might say, well, look at the drawing. Maybe it's like 2/3 of it, and 2/3 of 60 is about 20. So maybe one of them's 20 and the other one's 39. Well, you can't say that either, because you're just guessing wildly. Okay? The deal is they want us to use the segment addition postulate. The segment addition postulate says if we take EF and we add to EF FG, it says if we take EF and add FG to it, that is going to equal EG. That is going to equal the length of that whole segment, EG. That will equal EG. All right, so now we can make some substitutions. EF is represented by an algebraic expression, 8x minus 14. That algebraic expression represents the length of EF. So 8x minus 14 plus, and now similarly, FG is represented by 4x plus 1. So plus 4x plus 1 is equal to EG. EG is given. EG is 59. Okay, EG is 59. So that's a big mess on our hands, that big equation we've got to solve. So here we go. 8x and 4x are like terms. Hopefully you remember what to do with like terms, not cross them out. I'm trying to highlight them. My highlighter's not cooperating. It's been doing that this year. 8x, 4x, that's going to make 12x. Similarly, I can highlight and combine my other like terms here of negative 14 and 1, so that's going to be minus 13. Minus 13 equals 59. So I've got this equation to solve, so let's see. I'll go ahead and add 13 to both sides. So 12x would be is that 72, and if I divide by 12, I believe x is going to equal 6. So I don't know if any of you ever go grocery shopping. I know some of you are driving now. Some of you are just starting to drive. But imagine you went grocery shopping, and you probably have 37 bags, even though there's not that many groceries. But there's 37 bags, and they're all scattered in the back of your mid-size crossover. And there's milk back there. And there's probably some bread and some eggs. And today it's going to be about, 70-some degrees. Imagine if you just went inside and started playing video games. That'd be a good time. Imagine mom and dad when they find out that you left the groceries in the car. There's a point I'm trying to make here. If we just stopped at x equals 6, we didn't do anything to answer this question. We started, we went to the store, we got the groceries, but if you'd like to be able to use those groceries, you better put them away, bring them into the house. And what we did is we just kind of left the groceries in the car. So don't leave the groceries in the car or the mid-size crossover. Be sure to take the groceries in. Okay? So what I mean by that is we've got to do something with the x equals 6, because what we're asked to find here, ultimately, is what the value of EF is. So EF was represented by this 8x minus 14, 8x minus 14, and we said x is 6. That's going to be 8 times 6 minus 14, or 48 minus 14. So that's going to be 34. EF is 34. Maybe I should have used green because that's what I used earlier. EF is 34. Okay. So the cool thing is, now that you know what EF is, there's several different ways to get FG. I don't know why my highlighter's acting the fool. I'm trying to use the selection tool, and there we go. So EF's 34. You could just subtract from 59, or you could actually make the substitution. It's up to you. When we go to find FG, though, when we go to find FG, remember FG is going to be 4 times x, which you said was 6, plus 1. That's 24 plus 1. That's 25. FG is 25. FG is 25. So 34 plus 25 is 59. The segment addition postulate does hold. We did something right. Everything is copacetic. Okay. So again, just don't leave the groceries in the car. Okay. What I mean by that is the directions don't just say find x. You've got a little bit more to do. So got it, number 2. I'm going to go a little bit faster through this one, but we'll have 4x plus 6. Note a real common mistake that people make. They want to say that 4x plus 6 and 7x plus 15 are equal. We didn't say that. We said that that length plus the other length is equal to the total length, and the total length here is this JL, which is given as 120. Okay, so we're going to have 11x plus 21 is 120. So we'll have 11x is 99. X is 9. I can't stop there. So JK is 4 times 9 plus 6. So that's going to be 42. JK would be 42. And KL would be 7 times 9 plus 15. So that's 63 and 15. So that's 78. So KL is 78. 78 plus 42 is 120. We're good. Okay. All right. Moving right along then. What numerical expressions have the same value when you say they are equal? Oh, when? I'm sorry. I misread that. I'm a horrible reader. When numerical expressions have the same value, you say they're equal. If two segments have the same length, we use a different language. We say that those segments are congruent. Congruent. The sign for congruency is an equal sign with a little, I think that's a tilde. So an equal sign with a tilde, that means congruent. Okay. This is real important here what the book's trying to point out. When you're talking about the lengths of the segments are equal. When you're talking about the lengths of the segments being equal, notice no hat. Segments have the same length. When you're talking about the segment itself and saying that segment has the same length as the other one, but you're saying they're congruent, this says they're congruent. This says their lengths are the same. The numbers attached to them are the same. This says their lengths, regardless of the numbers, are the same. They're congruent. Okay. What else? As illustrated above, you can mark segments. Marking segments. So they're saying right here that if you have A, B, and C, D that are congruent, we use this little hash mark right here and here. That hash mark denotes that those segments have the same length. Okay. So sometimes it'll be helpful to mark up a drawing. You know, maybe something will be given like this. Maybe they'll have something like this. Here's A, B, C. They'll tell you AC is 38. Find AB. And you're thinking to yourself, I can't find AB. There's not enough information. There's no algebraic expression. There's plenty of information to find AB. You know that AB and BC have the same length. They're congruent. You don't know what AB is. So you would say, well, that's X. And you don't know what BC is, but you do know that when they're congruent, it means their measures are the same. So the one's X, the other one's X. So X plus X is 38. So 2X is 38. So X is 19. And X and AC are the same thing. So AB, actually, X and AB are the same thing. So AB would be 19. Okay. Problem 3, comparing segments. Are AC and BD congruent? Well, to find that out, we would need to find AC. Watch this. AC, no hat. AC would be the absolute value of -2 minus 5. It's the absolute value of -7. That's 7. BD would be the absolute value of 3 minus 10. That's the absolute value of -7, which is 7. So AC and BD have the same length. So are they congruent? Of course they are. Yes. Okay. Got it. It says use a diagram above. Is AB and DE congruent? So part A is AB congruent to DE. Well, let's see. AB is the absolute value of -2 minus 3. That's the absolute value of -5. So that's 5. AB is 5. DE is the absolute value of 10 minus 14. That's the difference between 10 and 14. It's absolute value negative 4, which is 4. So it looks like a no there, right? Those ones are not congruent. Finally got it, part B, the reasoning. It says, to find AC in problem 3, suppose you track negative 2 from 5. So they're saying when you found AC, when you did this, what if you had done that in a different way? What if you took 5 minus 2? Would you have got the same thing? Well, 5 minus 2, I mean. 5 minus 2, would you have got the same thing? 5 minus 2, would you have got the same thing? Yeah, because when you minus a minus, that's plus a plus. So that's the absolute value of 5 plus 2. The absolute value of 7, you would have got the same thing. So yeah, and the reason for that is because, I guess because we're using absolute value. Whenever you use absolute value, subtraction's commutative. Okay. All right, blank to fill in. The blank of a segment is a point that divides a segment into 2 congruent segments. The word that goes in there, if you can't figure it out, it's probably later on in the sentence, yep, or in the next sentence. A point, line, ray, or other segment that intersects a segment at its midpoint. So midpoint's what goes in there. Okay, if you're ever not sure what the word is, look a little bit further on and you can get the answer there. So midpoints bisect a segment. That point, line, ray, or segment is called a bisector. It's called a bisector. So a picture's worth 1,000 words. Suppose here's line AB, and here is ray. Here is ray CD, ray CD. So the deal is, in this particular instance, CD, ray CD, is the bisector of segment AB. We could say that. Okay. Now, to be clear, we would need to show that AC and CB or AC and BC are congruent. Okay. We could also say C is the midpoint. C is the midpoint of AB. Okay. Maybe that line continued. Okay, so in that case we could say line DC bisects line AB. Oh, actually, segment AB. You can't bisect a line, but you can bisect a segment. Okay. All right, so that's the kind of thing they're talking about. So problem 4, Q is the midpoint. Q is the midpoint. They're telling you Q is the midpoint. When they do that, mark the drawing. Since Q is the midpoint, it means that this and this part are congruent. They have the same measures. Their lengths are equal. So we can set 6x minus 7 equal to 5x plus 1. So now we can set things equal when we're given a midpoint. Subtract 5x from both sides. So we're left with x minus 7 is 1. We'd add 7 to both sides. So x is 8. And we left the groceries in the car. It doesn't ask what x is. The question says, what's PQ? Well, making a substitution, PQ is 6x minus 7. That's 6 times 8 minus 7. That's 48 minus 7, or 41. Okay, so PQ is 41. PQ is 41. If you wanted QR, you know PQ and QR are congruent, or you could do the math, make the substitution if you want. So QR is 5x plus 1. Now we said x was 8. So that's 5 times 8 plus 1. That's 40 plus 1, which is 41. It's never a bad idea to double check, to plug into both just to make sure you did this right. And finally, what is PR? Well, PR, let's see. If this is 41 and this is 41 by the segment addition postulate, I guess we'd have to double that 41. So PR would be 82. If you're not sure where that comes from, the segment addition postulate says PQ plus QR is PR. So 41 plus 41 is PR. And so that's how we would get the 82. Okay. I think most of you probably understand that without having to write all that up. But just to be clear, that's where the PR comes from. All right. Got it for, is it necessary to substitute 8 in for x in the expression for QR in order to find QR? That's an interesting question. Is it necessary to substitute 8 for x in the expression for QR in order to find QR? Not necessarily. In the general case, regardless of what x is, regardless of the numbers, we know that QR would be double PQ or double QR. I'm sorry. Hold on. Do we have to? Oh, I see what they're saying. I see what they're saying. They're asking. Again, I'm a bad reader. They're asking, do we have to do this? Do we have to do that? And no, we don't. But it's a good idea too. It's a good idea too. All right, part B, they're telling us another, basically it's another example here. So we would have the 8x, I said we'd have the 8x plus 11 is 12x minus 1, so we'd get 4x is 12 and x is 3. So 8 times 3 is 24 plus 11, so that's 35. So this should be 35 also, that's 12 times 3 minus 1, yeah, 35 and 35. So what do we got? TU is 35, UV is 35, and TV would be double that, would be 70. Okay. So hopefully this idea with measuring segments is making sense. Hopefully you're doing all right, keeping up with everything. Let's see what else we got. Lesson check, that's it. We're almost done. We are almost done. Just these few on the lesson check, and then whoever's covering my class, I appreciate you being there. I hope that this lesson has been informative. I hope that you learned something from it. I hope that the class is paying attention and not on their phones. The time that's left will be theirs to work on the assignment. Please don't line up at the door before the bell rings. I don't like that. Okay. So anyway, name each of the following. The point DA, the point on DA that is 2 units from D. What? I'm a bad reader. I got to read this one again. The point on DA. So I'm looking at ray DA. So I'm looking from here to here. So the point on there that's 2 units from D. Here's D, the point that's 2 units from D. I guess that would be the point B. All right. Let's go to the other one. Erase all that. 2 points that are 3 units from D. 2 points that are 3 units from D. So here's D. 1, 2, 3 units. So G's one of them. G's one of them. Could go 3 the other way. 1, 2, 3. So A. So A and G. A and G. All right. The coordinate of the midpoint of AG. Oh, the coordinate of the midpoint of AG. The coordinate of the midpoint of AG. So AG goes from here to here. So we want the coordinate of the midpoint. Something that bisects that. So AG is 6 units long. AG is 6 units long. So the midpoint would be halfway across. So 3 units over. So I guess that would be D, right? The coordinate of the midpoint of AG would be D. And finally, a segment congruent to AC. A segment congruent to AC. So if we look at AC, we would need to know its length. AC goes from -3 to -1. So that's what, 2 units in length. So AC is 2 units in length. It says name a segment congruent to that. Any segment 2 units in length would get this done. There's a whole bunch we could name. We could name BD, or we could name something else that's 2 units in length. CE. Something else that's 2 units in length. How about DF? Something else that's 2 units in length. How about EG? Any of those would work. Any of those would work. Okay. All right. Well, I think that's it. It's been real. It's been fun. I hope, again, that this was educational, and hopefully you have a few minutes in class there to work on the exercises. Chapter 1, Section 3 for homework. I'll check it first thing tomorrow. Have a nice day. Good.